My name's Liz. I work for a company called Aqua Security. If anybody's seen me speak before, I've done some talks where I've written a container in 60 lines of Go, I've written strace in 60 lines of Go. Today I am not going to be writing Vault in 60 lines of Go. So if that's what you're expecting, I'm afraid that you will be disappointed. But I am going to talk a bit about Vault, and in particular how we can use it to help us with managing secrets for containers. So just a little bit about Aqua Security. We have a product to help enterprises secure their container deployments. One of the things it does is help with secrets management. If you want to ask me about any of the other things it does, I will be here for the rest of the day and tomorrow. So secrets management can be done with Aqua, but it can also be done with other mechanisms. A lot of the orchestration platforms have secrets management capabilities. So that's really what I'm going to talk about, and in particular, how we can use Vault with that. But first, what do I mean by a secret? I mean things like passwords, API tokens, certificates, things that you don't want other people to get a hold of. I'm not talking about your vast database of people's social security numbers. Is Equifax in the room? I'm not talking about those big databases. I'm talking about the things that we use to protect those. The information that your code needs in order to access what it needs to access. So, your web server maybe needs a database password so that it can access a database to do whatever it needs to do. And we want to make sure that we can get that information to the code that needs it without anybody else getting to see it. How many people in the room are using containers? That's a pretty large proportion of you. Good. How many of you are using containers under some form of orchestration? Also, the majority. Good. So you'll all be aware that you are going to start some containerized code. It's going to land somewhere in your cluster. You don't know where. And the secrets management part of your whole sort of configuration needs to get the secrets to the right code at the right time. So let's think a little bit about desirable attributes, things that we would like to see from secrets management. So very importantly, we would like to encrypt our secrets. We want them to be encrypted when they're in storage, and we want them to be encrypted when they're flowing around between machines in your cluster. We really only want to see them in plain text, in memory, in the code that needs to use that password. Why do we want to keep it encrypted? Well, if somebody somehow gets access to your cluster, gets access to one of your machines, gets access to one of your containers, if the secret is in plain text, the job is done. If the secret is encrypted, they still have a challenge ahead of them. Kind of obvious, but ideally, we want to limit access to those secrets to the code that needs it. This may not apply to you. You may have a relatively small deployment, but if you're a large organization and you have a large number of secrets, maybe different products, different components that have access to different secrets, it's going to help if you can limit which containers have access to which secrets, because should anything go wrong, your exposure is smaller. If something does get into one of your containers, maybe it can only get to that small set of secrets that that container should see, and not all of the secrets for the whole deployment. That would be better. Similarly with users, if you're a large organization, you have multiple teams, those team members don't all need access to all of the secrets from all the other teams. A lot of the time, your developers don't necessarily need access to your production keys. So being able to control who has access to which secrets when, from a container perspective and from a user perspective, is useful. And then I also put write-only access on this slide. I was with a customer yesterday and showed them this slide, and he said, write-only? Are you sure you don't mean read-only? And I thought he was quite a sort of senior guy, so I thought it was interesting he hadn't come across this concept. So it's the idea that I can change a password, or I can add a password or a secret of some sort, but I can't necessarily read it back out again. And we'll see that later on. You might not need all these characteristics, but they're things to bear in mind when you're evaluating how you manage your secrets. And then finally, the life cycle of secrets and how your secrets management system can cope with this. So unfortunately, the more time goes by, the more likely it is that your secrets will somehow have been compromised. It might be because a bad actor has done a bad thing. It might be because somebody has been an idiot and, left a notebook on a train full of your passwords. Whatever, somehow, the more time goes by, the more likely it is that secrets will somehow have escaped your control. If you know that a secret has been compromised, you need to be able to revoke that. You want to essentially stop that one from working, replace it with a new value. Unfortunately, we don't always know when something has been compromised, so it's a good idea to rotate our secrets on a regular basis. That way the old values don't work anymore and they need to be replaced with new ones. And every time that happens, the revocation or rotation, we need to get the new values into the containers wherever they are. You may also have a requirement for audit logging. For compliance purposes, it's often a requirement to know which code and which people have had access to different secrets and when they've changed them and what's happened to them. You may need that for a kind of tick-in-the-box compliance reason. It can also be really helpful if you're doing a forensic investigation after something bad has happened. So that's kind of talking in the sort of theoretical sense about what we'd like to see from secrets management. Now let's think about the practicalities of how we actually get a secret into a running container. And I'm just here talking about the bit where you execute the code and it's got to be able to read that value. And we'll start with some really bad ways. The bad ways are to bake the secret value into the code somehow, or bake it into the image. Probably half of you are sitting here going, yeah, of course that's stupid, and half of you are going, yeah, no, never done that, no, don't look at me. In case it's not obvious to you, if you have your secrets in your source code, you've made those secrets accessible to everybody who can see the source code. Open source, that's a really bad idea. Even if it's closed source, you don't necessarily want all of your developers to be able to read all your secrets. The other thing is you've coupled changing your secrets with changing your code. You need to deploy new code if you want to deploy a new secret, and that's probably not a good idea. And if you're the security person who wants to wake up a developer to say, hey, it's 3 a.m, but I need you to deploy a new secret, you're not going to be very popular. So yeah, don't put your secrets in the source code. So if they're not going to be in the container image, we're going to have to get them in at runtime. And there are 2 methods for doing this. One is to use environment variables. So let's actually just take a look at doing this. Is that big enough? Can you read that, or do we want to go a bit bigger? Okay? Good. Thumbs up at the back. Good. Right. So let's do Docker run. We'll get rid of it. I'm going to give it a name. We're going to pass in something like secret is my password. And we'll run an Ubuntu container, and we're just going to run a shell. Kind of obviously, if I look for, oops, can't type. Kind of obviously, that value is in the environment in the container. Anybody who can exec into that container will also be able to read that secret. In case you don't know, it's also accessible from a couple of other places. So we can, for example, inspect that container. I am only interested in looking at the, oh, no, Jason. I only want the environment. And we can see anybody who can run Docker inspect, possibly remotely, not necessarily on the exact same machine, can see that environment variable in the clear. And that's from where it was passed in that sort of run command. Also, I'm just going to send this to sleep for a little while so that I can find process ID inside that container. Now, I need to be sudo or root to do this, but inside the /proc directory, there is a ton of really interesting information about running processes, including the environment. These are null separated, so I'm just going to convert the nulls into new lines. And we can see somewhere, there it is right at the top, there is my secret. Now, you can make a very strong case that anybody who has root access to that machine and can do that, there are all sorts of other issues you have anyway. So it's just something to be aware of, that anybody who can get root access on that machine can read all of your secrets from all of your running containers, no problem. So with environment variables, just to recap, anybody who can run Docker inspect, anybody who can exec into the container can read the environment. Root can get it out of the /proc directory. But perhaps the sort of most compelling reason to not use this mechanism is that environments are logged a lot. Quite often, software, when anything goes wrong, it will dump the environment to some log file, which now then contains all your secrets in the clear, accessible to anybody who can read those logs. So for that reason, quite a lot of people will say environment variables are a bad mechanism for getting secrets into containers. You should use the alternative, which is to mount a volume. So you have a volume on the host containing files containing your secrets. The code inside your container can read those secrets out of the file. But wait, Liz, I hear you say. You said don't write your secrets onto disk. They have to be only unencrypted in memory. So what you want to see here, and this is generally the case, is that those volumes are temporary file systems. Temporary file system looks like a file system, it has things that look like files and directories, but it's actually only held in memory, not on disk. So that's good. How does this compare in terms of ways that people can get to those secrets? Well, the Docker inspect thing goes away. If I run Docker inspect, I can see the fact that volumes are mounted, but you don't automatically get like a dump of all the files inside those volumes. So people can't just easily grab your secrets by running Docker inspect. Anybody who can exec into the container can, of course, read that secret. The /proc directory thing is still a risk, again, only for people who are root on your host, so probably you have other concerns, but you can read the root file system of a container from inside that directory. One thing that does go away, as well as Docker inspect, is the logging thing. You're unlikely to see sort of routine logs of all the files. So having a mounted volume holding your secrets is probably a slightly more secure way of going about it than an environment variable. If there are still risks either way. So that's talked about how at runtime the secret gets from the host into the container. Now let's have a look at the ways that some orchestrators support all these sort of features of secrets management. So since we're at HashiCorp, let's talk about Nomad. Who is using Nomad? Okay, so as I rather suspected, a lot of you are using orchestrators that are not Nomad, and that's not a surprise. Nomad does have really nice secrets management integrated with Vault, though, so it is one thing that is very strong about the solution. A few things to bear in mind. You have to use Vault in production mode, but they say that really clearly in the documentation. Don't run in development mode for production. Vault is giving you encryption out of the box. It's giving you these security primitives that Nomad that can then use to take care of everything we're looking for from a secrets management solution. The secrets can get passed into your job, container or otherwise, as a file. And Nomad will look after the exchange of tokens required to get that secret information out, and it can poll so that if you want to change your secret values, if you're rotating or revoking a secret, it can bring your container up to speed. And it also takes care of the access control things that we might be looking for and the audit logging that we might be looking for. So I'm going to give the Nomad plus Vault combination 3 ticks for the 3 different things that we're looking for. But as we said, not everybody is using Nomad. Some people might be using Docker. Anybody heard of Docker? Yes, of course you have. So out of the box, Docker Swarm has some pretty nice solutions for managing secrets. Only works for Docker Swarm services, not for containers that you run by typing in Docker run. Swarm will set up encryption between each pair of nodes. They're mutually authenticated. This all happens for you without you having to do a single thing out of the box. So very nice and easy to use. Docker only support the file system or the volume method for getting secrets into the containers. I think they're very opinionated about not using environment variables for the logging reason, which is a completely valid opinion to hold. In terms of the access control, if you're using the Enterprise Edition, they do have role-based access control. And they also have things like the audit log solutions baked in. Couple of things to bear in mind with the Docker solution, though. First of all, secrets are held in the Raft log. Raft is the mechanism that the Swarm managers use to communicate with each other. And this is the one thing that doesn't kind of happen automatically out of the box. You have to explicitly say, I want to lock my Swarm. Otherwise, although everything is encrypted, and that's all beautiful, there is an encryption key sitting right next to your host. So you want to just be aware, if you're using Swarm, make sure to lock it, otherwise all that encryption is not as secure as you would hope. The other thing that isn't quite so strong with Docker, we can see if we just have a quick look at some of the help for that. So if I look at Docker secret, we can see you can create, inspect, list, and remove secrets, but you can't update them. You can't change the value of an existing secret. If you're running a service that has access to one of these secrets, you can add new secrets to the service, so you can do a rotation by creating a new secret and deleting the old one. But it's a kind of, there's a couple of steps to that process. It also requires the container to restart. That could be absolutely fine. We're all writing our container code to be cattle, not pets, and to be able to restart at any time. This is probably absolutely fine, but just a thing to be aware of. When you want to rotate your secrets, when you want to revoke a secret, it will involve a container restart. So for that reason, I'm not going to give them 3 out of 3. I think the lifecycle management could be, it could be easier to rotate a secret than it is with the Docker solution. And then finally, Kubernetes. Who is using Kubernetes? Yeah, okay, few hands. I apologize if I've not mentioned your favorite orchestrator. There may be a few others. So in Kubernetes, secrets are managed as, or they're set up through YAML files, like everything. It supports both the volume mechanism or the environment variable mechanism. You immediately get namespacing for access controls. So like a lot of things in Kubernetes, things are namespaced, so you can only see the secrets that are inside the namespace that you're looking at. And I can't quite remember which version, I think it might be 1.7, RBAC was introduced, so you can turn on role-based access control and limit access to the different secrets. Secrets are stored in etcd, and only recently has etcd been or had encryption support in Kubernetes. You have to go through a bit of work to make sure that they're encrypted. So for that reason, I'm not going to give them the 3 out of 3. It's possible, and there is a lot of work going on in the Kubernetes community to improve the ease of using a lot of secrets, a lot of security features, including secrets management. But out of the box, it's not as easy to use as some of the other alternatives today. So we've seen that the Nomad plus Vault combination was really strong, and Vault is a really nice way of getting a bunch of the security primitives that we want. It gives us the encryption out of the box. It gives us all these nice sort of token renewal features that are really strong. So it would be great. What we want, really, is to use Vault to manage the secret storage and use that in combination with whatever orchestrator we want to use. And the good news is that that is indeed possible. So we talked about Nomad having integration. Docker are working on a plugin backend approach for secrets. So Vault will, I believe, be one of the backends that will be supported by that. So you'll be able to use the same Docker Swarm commands and the same Docker secrets commands, but they'll be stored in Vault for you. Kubernetes, there is an existing project, Kubernetes Vault, that will let you use Vault for the secrets backend for Kubernetes. And I'm not sure whether some of the announcements this morning will also make Vault Kubernetes, well, it will make a Vault and Kubernetes integration easier, whether it covers secrets. I'm not sure yet, because I only heard about that this morning. And then another approach is what we have at Aqua, which will can use a number of different secrets backends, of which we support Vault, and use that to inject secrets into running containers through Aqua code alongside any orchestrator. So I'm going to just show that. So I need to just get my Aqua screen up. So with Aqua, we're running a piece of agent code on every node in a cluster. I've got a single node cluster on my on a virtual machine here. And I have a secret store set up to use Vault. So that's one of the places that I can store secrets. And I can configure a secret. This is what I meant about write-only access. There is a secret here, but I can't read it, and all I can do is change it. So let's change it here, and I can save that. And then I can, oops, that wasn't what I wanted to do. Oh, God. That's crazy, wow. Right, I won't try and reverse search, I shall just type it in myself, right? So I'm gonna run what I wanna do. So I need to pass in, now rather than pass in a secret value, I'm gonna pass in like a key to the secret, which is this. Okay. Let's call it Ubuntu again, and we'll run a shell. Hopefully that's all I need. Right, so similar to what we did before, we can look for that secret, but rather than getting the key to the secret, we can see the value that I just typed in. Okay. That value has been stored in Vault and retrieved by the Aqua code. I can run inspect on that container. I'm going to do this format thing again. And now we've got the key to the secret rather than the secret value. So if somebody has the ability to run Docker commands on this machine, they don't automatically get to see the secret. We'll do that sleep thing again and find the process ID and take a look in the proc directory, 19297. Byron, translate the nulls into new lines, and let's just find secret. And again, we only see the key to the secret rather than the actual secret value of hello Austin. So we've removed some of the concerns about using environment variables by using this mechanism. This is also injecting the secret into a file. So again, that's available. If you want to use the file mechanism, you can. And it's also possible to use a slightly different environment variable in the run command, which will say only use the file version, don't use the environment variable. So if you're concerned about the logging issue, that is also possible. And then let's see what happens with rotation. So I'm going to change this value again. Save that. And we'll look at that environment again. And the secret has been updated without a container restart in the environment. It has also been updated in the file version without a container restart, which is pretty neat. You might not need that, but it's there if you need it. So that is taking advantage of the, let's go back to present, all the goodness of Vault for encryption and the token management. We had to pass in a token from Aqua to be able to get access to these secrets. We've avoided some of the ways in which environment variables get leaked. So there's no leak through the Docker inspect or through the /proc mechanism that way. Oh, I didn't show you the audit logs. So if I look in here, we should see, yeah, we can see where I updated it. We can see that every time that a container gets, that a secret gets used by a container. And in fact, if my container is still running, I can look in here and see which containers are using which secrets. So if we learn that a secret has been compromised, this could give us a sort of handy shortcut for figuring out which containers need to be affected. There's also the ability to limit access to secrets by different containers using labels, and there's a whole role-based access control system built in there. So by using the Aqua injection mechanism plus the storage in Vault, we can get all those three ticks again, and we can get that whichever orchestrator we're using. Okay, so I am pretty much going to wrap up. The key things I want you to take away. First of all, if you are writing your secrets in source code, please stop. Don't do that anymore. When you're thinking about secrets, like everything in security, there's no perfect solution. All you can do is reduce risk. And you need to have a think about what risks you're concerned about, what your kind of priorities are. And I wouldn't say choose your orchestrator on the basis of its secrets management. You want to choose your orchestrator on the basis of its orchestration capabilities. But in many ways, your secrets management may vary according to which orchestrator you're using. Whatever, Vault does provide really great underlying security primitives the storage solution for secrets, and the ability to then actually have Vault using a backend that the secret data can be held in a variety of different sort of physical storage mechanisms, gives you the ability to tune that to your particular environment and your particular requirements. Okay, so the last thing I will leave you with is that we wrote a white paper about secrets management. So if you have questions and concerns about secrets management, you may find the answer in that white paper with a nice little easy to remember URL. And as I say, I will be here for the rest of the day and most of tomorrow to answer any questions you might have about container security or about writing anything in 60 lines of Go. So thank you very much.
Thank you very much.